Mi tema es hablar de entender la relación embriomaternal, la parte inicial del embarazo. Una parte de la vida de la mujer quiere embarazar, otra parte de la mujer no quiere embarazar. Yo voy a dar una presentación que habla de si la persona entiende la relación fra embrio y maternal, puede del futuro haber posibilidad de crear algo cuando la mujer no quiere embarazar. Okay, from now on, I'm going to continue in English, but I hope you got my Spanish introduction. So let's see, let's start here. So the basic idea is to understand embryo-maternal relationship. And my focus was for the last several years to understand how early the mother being aware of the presence of the embryo, because we speak about start of pregnancy. So for a long time, the thought process was that it's at implantation, when the embryo is really stuck on the endometrium, then there is recognition of pregnancy. And biologically did not make any sense, because once fertilization can happen, it does. Therefore, the mother should be aware what's going on, since almost it's an active process of egg pickup and fertilization. So it is not something that you are become not aware. The second part, which was very important to see, is that when you have in vitro fertilization and you transfer the embryo, it takes 4 to 5 days until the embryo is recognized by the mother. So when we look at these things, we start trying to understand why in early pregnancy, why the earliest stages, the communication embryo and mother starts and how early it does. And my work was, let's see, how you advance this one? That one? Okay, very good. So my work was to speak about a reproductive odyssey, because if we understand one thing, we can understand the intimate relationship between embryo and mother and how it is evolving and what makes success and what makes failure. So if we look at it, we speak about reproductive odyssey because in a way pregnancy is against odds. The loss of chances of having a pregnancy is actually rather low, but on the other hand is quite high. And therefore we're going to speak about embryodromal dominance and signaling. Why the embryo is able to transmit a signal and why the maternal system responds in kind. Because if the embryo is non-viable, there is no reason that the maternal system will respond. And therefore, that my focus was to identify the government signal that's coming from the embryo and leads to maternal recognition. So what I speak about is called translational science. And the question is, ask not what you can do for the embryo, ask what the embryo can do for you. We look at it on that the embryo is a very weak, vulnerable, but extremely potent, because if you think about reproduction, the embryo can implant in the uterus, in the tube, in the abdominal cavity. So it is acting like a parasite. And if you speak about donor embryo, genetically have nothing, but still the success is very high. So therefore the embryo has a driving force. But on the other hand, the maternal system has to provide quality control. Either I like you or have a nice day. And therefore that balance between embryo dominance and maternal environment, which is responsive, that's what creates gestation or lack of gestation. So what I'm trying to do is to pursue clinical application, because once you understand that embryo-maternal relationship is very critical, I have identified something called pre-implantation factor. And why it is called pre-implantation factor? It is a peptide coming from the embryo, already the 2-cell stage, and initiate the embryo-maternal communication. So the phase 1 is maternal recognition of pregnancy. Number 2, maternal adaptation. If I recognize you, then maternal system also will adapt, because there is no reason to have a recognition. If no recognition, why should be an adaptation? Why? Because maternal system pays a price to adapt to the embryo. So these are the books that I kind of published about early pregnancy. And I think that was stated that I have 400 publications. I have only 240. So let's not overstate it. You know, it's enough, but it is enough. I'm very proud of one book because I did it with Bob Edward, the father of in vitro fertilization. It's called Embryonic Medicine and Therapy. So that's something 20 years ago. I had really the opportunity to work with Bob Edwards, who did the first in vitro in the world. So, question: when does a viable life begin? Very good question. Do we have the answer for that? So then we can look at it as a reproductive odyssey and look at it very carefully. What are the odds of having a healthy pregnancy? As an egg during fetal period, very, very low because you have hundreds and thousands of that. And if you look toward conception, around 33%, moving to 66%, 80%. What it means is that once you reach to the point of implantation in early pregnancy, the likelihood of loss of pregnancy becomes very, very small, maybe 2%. That means the embryo quality counts, but maternal system is very vigorous to say, keep it, reject it. But once that passing, look at the numbers, 88%, 97%, 99%. So by the time of birth, unless there is maternal complication and fetal complication, very, very high take-home. So the system of 005 in prenatal period, the fetal ova, up to 99%. That means from 2 million going down to extremely low rate. Therefore, every product has to be very well selected. And when you look at it in the embryo odyssey, very low odds, high quality take-home outcome, live birth rate 2 out of 2 million of fetal organ. Why? Because a woman usually has 2 children in general during pregnancy, but she started with 2 million oocytes. Therefore, when you have such a high selectivity, that's the reason we speak that most pregnancies are really successful when they reach beyond the embryogenesis. And that's something has to be kept in mind, that we are very lucky that sperm produce non-stop, but eggs produce only once a month, 1 or 2 eggs. And it comes for 2 million that started during fetal period. So nature builds selectivity, and by bringing selectivity, it reaches to that quality. Selectivity related to quality. And that's the reason when women use contraception, they are very selective after to be able to have high quality pregnancy. And then if you look at it the other way around, fetal period 005, delivery 99.9. And once you see that analysis, you understand it, you say, I have to be really making sure, but each time I stop the contraception, I create a right environment to do good quality pregnancy. Because, you know, women want contraception, pregnancy, contraception, pregnancy. So if you do a good quality contraception, the pregnancy should be coming of good quality, because that starts and finishes in that order. So let's speak about embryo-driven dominance and signaling. And what I look at it is that pre-implantation factor, it's called PIF, it is called that way because it's a peptide starting from the 2-cell stage embryo. And it exists in the human, in the cow, in the horse, in the pig, in the panda, you name it. And therefore, if you look at it, these are the functions of PIF in pregnancy. It is secreted and targets the embryo. The embryo is a parasite. Therefore, something comes out of the embryo, targets the embryo. It has a trophic and protective effect. Remember, parasite need its own defense system. Second, you find it in the cultured media, and you can relate it to embryo viability. If the embryo is viable, it is a marker for it. And therefore, PIF pregnancy-specific embryo signal, and you can speak about the role and action from fertilization delivery, from pre-implantation up to implantation. And this is coming signal, interaction, and then it happens. So therefore, when you look at it, you need a maternal recognition followed by maternal adaptation. And therefore, what we look at it is that something that starts leads to the end, to a finish. And therefore, PF is involved from the earliest stages of gestation until end of the gestation. And what I'm going to talk to you about, its function. So what is very important to realize that nature has a gift. And through 200 million of evolution, PIF sequence from mouse to man have never changed. Therefore, something that it stays so much during reproduction process from the earliest mammal until present is very important, and to us gives a good satisfaction that the same mechanisms are operative from mouse to man, and therefore the embryo-maternal relationship, once evolution allowed for mammalian development, led us to have this PIF, and therefore my job was to try to understand its biology, its function, and what it does. So when we look at it, is that what PIF does, it targets embryo and mother, and then you have to look at it, what are the elements it does. Since the embryo is more vulnerable in maternal system, what is the first thing that you have vulnerability on the cellular level? Oxidative stress. Every cell, first time is damaged, is called oxidative stress. And therefore, PF major target is thyroreducin, which related to oxidative stress. And why it is important? Because if the embryo is exposed to adversity of the maternal environment, there is no reason for it to develop. So it helps to self-elimination. The second element is called heat shock protein. Why? Because the protein are being damaged. First, you create stress. Second, you create damage. And what PF target those two lead to restoration of the cellular function, because the embryo live or die based on those two elements. And the third one, which we find it as a receptor for PIF, related like cortisone binding site. So it acts like a benign corticosteroid. And that's the reason it has immune regulatory and does not have immune inhibitory effect. So if we understand more embryo-driven dominance and signaling, we try to understand, is it true? And what you see here, that only PIF, positive embryos, lead to live birth. That means, if you look in the cultural media and you try to transfer PIF negative embryos, they do not implant. And this was done at earlier study showing 18 out of 18, zero pregnancy. That means it's a very critical element in embryo-maternal relationship. On the other one, which was positive, came around 25% take-home baby. Why? Because the maternal system is involved in quality control. And as you see below, if you have an observation by ELISA, you need to confirmation by amino acid analysis. And as you see, it is in embryo culture media, 15 amino acid, it is present. So you have two-level confirmation, antibody base, amino acid base. And then what we show as we published, PF present correlates with embryo viability, detection in embryo culture media. We did it in cows. And what it shows, that PF secreted only by viable embryos, but it is not by atretic embryo. So it's an index of viability. And why it is important? Because if this signal is not emitted, the maternal system should not respond. If the material are not responding, there's no reason for pregnancy to take place. Okay? And therefore, we looked at it also in the circulation. This is again from cow pregnancy. And you see day 10 already, detection correlates and enables function with live birth. Already day 10, the pregnancy may be decided, yes or no. And as you see by day 20, the separation from the upper to the control, almost 95% prediction. So therefore, the destiny of pregnancy happened very early in gestation. And either the maternal system adapt, and then she's really go for it, or it will disappear. And that's the reason that selectivity is so powerful. And therefore, what we look at it now is PF has local and systemic immune homeostasis. What happens in pregnancy? Do we have immune suppression? or we have immune tolerance, we have immune adaptation. For long, long years, people speak about that the pregnancy is the immune suppressed state. But look at the pigs, look at the horses, look at the cow. When they deliver or during pregnancy, do they get sick? And they eat garbage and they eat a kind? Therefore, the system is immune altered to adapt. But one thing it's not an immune suppressed. Yes, certain viral condition a little more, etc. But actually, pregnancy is not an immune, but it's an immune altered, immune adaptive system. That's the reason most pregnancy, when they reach the first trimester, they're very successful until end of pregnancy. And then mammals thrive very well. So what we showed that PIF has local and systemic immune homeostasis. It promotes embryo development, autocrine effect, and protect against pregnancy loss. Because the embryo view it as a parasite, and therefore it has to fetch to itself. The maternal system is an only a tolerating environment, but unless the embryo has its own innate force to protect self, pregnancy would not take place. And then, what we look at it, that PSF promotes embryo development, it is actually the original stem cells. It binds to critical proteins in the embryo. And as you see on the upper, PIF, which is fluorescent-based, is uptaken by the embryo. So those targets that I mentioned are specific receptors for protein in the embryo, and it showed that PIF on the lower part, it promotes embryo development. Short-term PIF, put it in the culture media, lead to promotion of embryo to the blastocyst stage. And then what we look at it is protects embryo against adversity. Very important, oxidative stress, recurrent pregnancy loss. And this is the data to support those observations, because if you create this oxidative stress environment and you add PIF, it's protected and let the embryo develop to the blastocyst stage. And also if you take serum of women who have recurrent pregnancy loss and you put it in the cultural media and you add PIF, it negates that activity. So overall, PIF helps the embryo to do better in an adversity of maternal environment. And then, as we look further, we speak about endometrial receptivity. Very important. Think about like this: maternal recognition of pregnancy followed maternal adaptation. What is maternal adaptation? I fertilize this day, takes almost 7 days for implantation. What do? I have to prepare the endometrium for receptivity. Are you receptive or not receptive? And if you're not receptive, nothing can be done. So what PIF does, it promotes endometrial receptivity. Therefore, it creates that hiatus between fertilization to implantation. So by the time the embryo reaches into endometrium, the maternal system ready implant. And therefore, there is a very narrow window of implantation. You miss it, tune in next month. So therefore, if we look at it, what PIF action is, SPIF promotes embryo implantation, create a favorable endometrial environment, and it likes a continuum. Before implantation helps increasing the integrin in the endometrium to make the endometrium more favorable. During implantation, it creates a more immunological and ability to invade. And after, promote decidual function and embryo development. So what we speak about like a seamless interaction, because the embryo all the time is aware, if my environment is favorable for me, because I can fail pre, during, and post if the environment is not right, one, or my quality is not good. So the interplay between embryo quality and the endometrium. And then what we'll show here, PIF promotes endometrial receptivity starting prior to implantation, and you speak about integrin, we speak about it, this is all GeoGrow, MSC3, and ICM. So we start off entering to the biochemistry. This is kind of evidence showing what I was showing to you that are related to mechanistic understanding, specific pathway involved, and think about implantation is a very complex process, so it's not the time to go over to every mechanistic, but this is give you a sense, because beta integrins are very important for implantation. And then SPIF adapts endometrial receptivity to need at implantation and during first trimester. As I told you, it's a continuum. And when there is a continuum, because either the system flows or for instance stops. So you have to do pre-implantation, during, and post-implantation. And this gives you data. So now we are looking into trophoblast. What is a trophoblast? Trophoblast is a almost precancerous structure. It wants to invade and it wants to destroy. So if you go to molar pregnancy, it will keep on going on you. So what you need to do, allow it to advance, but don't allow it to advance too much. So what we speak about is that promote trophoblast invasion, but control it that will not be excessive. And what is PIF action created that balance, because otherwise it becomes a very aggressive thing, and as you say, it can transform to pre-malignant. And what we show that PIF promote tolerance and acceptance, for invasion. And what is the evidence? One, that if you look at PIF, it is expressed in the earliest part of the implantation phase, because you find it, you see at the implantation site, the trophoblast already is a leading part expressing PIF. So it's not secreted only by the embryo, but is also secreted by the earliest trophoblast, and it is the leading edge. And being the leading edge, create the first seamless interaction with the maternal system. And that is something very important. And then what you see, that the level in the first trimester is high, but as you go toward the end of pregnancy, very low. Alpha, omega. Tolerate, keep, reject as delivery happen. And that's what will happen. This is called the cycle of pregnancy. And then, very important, tolerance. What we spoke about, for example, one of the major markers is called HLA-G. What it does is a tolerance without suppression. It just creates an environment that I want to favor this pregnancy to continue. It will be limited. I'll be observing. The maternal system all the time is very aware of what's going on. And once that time happens, PF goes down, pregnancies end. And when you see on the lower part is that PIF much better than progesterone in promoting HLA-G in side-by-side study. What it means, if you think about progesterone, progesterone is a late comer to the trophoblast. PIF is there on the earliest stage of the trophoblast. Therefore, when you look at it, what PIF does, one, it promotes progesterone secretion in the trophoblast. Number two, promote the progesterone receptor. When you take those two together, there is a synchrony between progesterone action and PIF in order to promote pregnancy, because progesterone is present in the trophoblast around 8 to 9 weeks of gestation, and PIF already present already in the two-cell stage embryo. That synchrony is critical for pregnancy success. And as we look further, PIF integrated local and systemic protective effect, reduce at-risk pregnancy. And we speak about natural killer cells. Recurrent pregnancy, people believe that if you have a high level, and what PIF does, it reducing cell cytotoxicity and CD69 expression implication for recurrent pregnancy loss. And then it prevents fetal loss, but modulating LPS-induced inflammatory response, and also present in preeclampsia, possibly that has some action to protect as well. So when we look at it like this, SVF prevent maternal hostility to embryo in reducing systemic NK cytotoxicity and targets uterine NK cell. So you think about it like this. We have action periphery to reduce NK cells toxicity, but also target locally uterine NK cells. So it's creating a balance, not only one side, because many drugs, if you look at it, they work either one side systemically or locally. And PF has an integrated effect. And here in below that, you see how it's reducing CD69 expression related to NK cell toxicity. The other thing that we can see here is that reduces fetal loss in intact immune system. So if you think about from the early pregnancy, success and failure is driven many times by the embryo, but also the maternal system has to do it. Here we speak about a model of intact immune system, and what we found that PF reducing spontaneous threefold and inflammation induced twofold fetal demise. And he speaks about that the action is also local and systemic. It acts on the placenta and also locally acts also in the circulating cytokines and chemokine. What was very interesting to see is that protect against fetal loss weight, but does not affect the placental weight. So it creates a protrophic for a pregnancy to be of good quality, while does not over-enhancing the trophoblast weight. So by doing that, you create, the PF helps the environment which is adverse to the embryo to be successful during pregnancy. And then when you look at it also, PF protects against prematurity. It promotes progesterone action in the trophoblast, and you can see the receptor and the secretion in the trophoblast. What is important to see that the next thing which we looked, hold on, doesn't advance. No mass? Okay. Yeah, so here it is what we did. The PF reduces inflammation and prevent preterm birth. And this was something recent paper, which I want to go over it with you to do. We looked in the model because what is a major problem today and in many developing countries? Prematurity. And what we did a model of inflammation in an immune intact system. And what we found that SPF reducing fourfold premature delivery in an intact immune system. And therefore, it could be in the future, what I mentioned to you, could be utilized as a preventive of reducing of patients who are at risk. But this data, I think, tells us a very clear story that is able to do that. So that is number one. The second point of this, which was very important, let me go back, it protected the fetal brain against inflammation. Because what happened prematurity? Not only the mother suffers because all the things that she does, but the fetus it is. And what we found is that what PIF does is reducing fetal brain inflammation. So therefore, not only that you able to reduce, but in case there is, you can protect the brain, because what is the most vulnerable part if you're born prematurely is the brain. And that's what was very important to show, and here is the data to support it, okay? And here it is speaking about how it is done and what are the mechanisms involved, you know, because whatever I tell you on general terms, there is hardcore evidence for cytokine, chemokine, pathway, gene expression, all to support it, but I wanted to give you a generalized view of things, and I have all the publication, if anybody interested, to support those observations. So for example, this is lower premature fetal brain inflammation, increased number of neural cell progenitors. So this not only protects against inflammation, but also mature the fetal brain toward newborn formation. And that is critical because many drugs maybe have a little lowering of this, but do not have that dual effect. So we hope one day that will be utilized. And then you move to the newborn, you say, okay, the baby was already newborn, and what we show is PIF bolstered neuroprotection, protects neural repair following complex brain injury. And we found very recently, for example, is better than hypothermia. We did some study, we're working with the NIH on it. So that means if you think about the integration from conception until delivery, PIF is a pro-embryo, pro-fetus activist, you know. And when you look at it, they said, wow, it's interesting that why, one, it promotes implantation, and second, even help for the newborn brain to do better, because it is through evolution. The embryo had to acquire those qualities in order to say, if I create a pregnancy, these are mammals, remember, we are not birds, we are not marsupial, I need to have that ability to be a guardian of the embryon health from start to end. And I think the data that I generated with you and explained to you are really supporting those observations. So I think that what we look at it in the last part is just targeted systemic immune system. We discussed about it, that immunity has to be a homeostasis and not suppression. Should be tolerance and not suppression. And I think I showed you what are that oxidative stress, protein misfolding, and acting like cortisone. So if you look on those things, that's the reason the majority of pregnancy are healthy. Only the minorities are not healthy. Why? Because the embryo, instead of having adverse effect on the maternal system, it created that balance. And therefore, pregnancy, unless prove me wrong, of course, if you're genetic thing or if you have a very serious disease, is healthy. So mammalian evolution was able to develop because that fine balance. Before that, there was in the bird was the egg. This thing was not developed. The marsupial was partial. But in mammals, had to have that ability. I carry you, but I am also your friend in the success. You're not only a vehicle of transportation. I don't know how to explain it exactly, but that is very important. So, and this is kind of give you a sense that if we go beyond pregnancy, and we are very lucky that we are able to generate the synthetic PIF, and when you look at it, I'm not going to enter into detail, but there is a whole presentation. It regulates inflammation, immunity, and transplant. Once we understood that kind of critical interaction, and were able to do the synthetic PIF, we speak about radiation, we speak about graft-versus-host disease, prevent diabetes, brain injury, reverses paralysis, has so many applications. And those are hopefully, we already finished phase 1 clinical trial with the FDA for autoimmune disease of the liver. And now we are preparing now phase 2 clinical trial for graft versus host disease with major cancer center in the United States. Because we've shown safety, we showed efficacy in the whole lot of preclinical model, and then we are ready to go to the next phase of clinical translation, learning from the embryo and applying outside the pregnancy as well. So these are the things that we learned from the immune system. Target immune system in vivo, bind to specific receptor. It acts like a benign steroid, regulate innate and adaptive immunity. You maintain homeostasis, but if the immune system too active, you bring it down. And the effect that I showed you is integrated, is local, systemic. It's true in pregnancy, also in other things to do. And protect the embryo, reducing fetal demise, restores function, and has a regenerative property, because I showed you it promotes neural cells development, and that one. So I would like to, this is my conflict of interest, just to understand who I am, and thank you in the name of the embryo.